Hello, welcome to our video. Pause the video and read this problem as I draw a quick diagram. And yeah, okay, so this problem essentially includes a ball with fluid inside, and so it's a little tricky, but it's still pretty easy. So the main point over here is we want to find acceleration. So we want to think about angular acceleration. We can find that through torque. Torque equals I alpha. So we want to think about what we know. Let's think about rotational inertia first. Do we know rotational inertia? Yes, we do, because okay, so there's a caveat with this problem. Even though it's filled with fluid inside, the fluid is frictionless, so it doesn't really impede a hollow sphere from rotating as it normally should. So the rotational inertia is just the rotational inertia of a normal hollow sphere, but this is about if the axis is about the center. There's one more place where the axis could be, which is about the point on the ramp. And normally, physics problems will only have these two axes, which you have to consider which one to use in this specific case, like where a ball or a circular thing is rolling down a ramp. There's these two axes which you have to consider which one to use. And that all depends on what things you're given. So if you're given a certain weight over here, then obviously you would want to set your axis over here, because only if you set your axis down here will you know torque equals I alpha. However, if you set your axis over here, you're essentially canceling that out, because this weight right here has zero torque, and there's going to be a frictional force acting over here which provides a torque for spinning, which you don't know. However, it's same as vice versa. If you knew the frictional force acting over here, then you would want to set your axes over here so as to be able to use this equation. So in this question, we know the weight because there's both fluid and ball. So this weight right here is just 2 mg. So the torque acting upon it is, well, once we set the axis, let me erase this red dot right here. Once we set the axis to this bottom part of the ramp right here, then the torque acting upon it is 2 mgr. And then one tricky thing is we have to use parallel axis theorem along with this. And this right here, a bit offline, should be our answer once we solve for alpha. And this is essentially just the solution outline, because I won't actually be doing computation. Wait, hold on. I literally just solved it. There's just one more step. We have to sub in alpha equals acceleration over r, because I believe we're finding linear acceleration. And yeah, that's it for this problem. Thanks for watching.